Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our lesson for lesson 7.1.3. This is identifying and describing association. And in this activity, this actually is an activity that takes a little bit of time, which I found the amount of time we have in class these days is not nearly enough time, but we're going to do the best that we can. And if you're viewing this video in the future, maybe we've got 60 minutes or more to work on this, but right now we don't have nearly that amount of time, but we'll do the best we can. Okay, so this particular activity is actually the type of activity that really blends science and math together. The data analysis portion of science, which is mathematical in nature, and of course the topic is going to be scientific in nature. So let's just get right to it. It says, when is it reasonable to make a prediction? For example, when you know the height of a tree, can you predict the size of its leaves? Or if you know the outdoor temperature for the day, can you predict the number of glasses of water you will drink during the day? In lesson 7.1.2, you found that some data sets were related and others were not. In this lesson, you will look at different situations and decide if they show relationships that allow you to make predictions. As you work, use these questions to focus yourself and to help direct you. I guess you're not discussing, just focus your thinking. So when one value goes up, what happens to the other value? Now remember, we're talking about two variable situations where you've got like an independent variable and a dependent variable. So when you change one, what effect does that have on the other? Does it go up? Does it go down? Does it have no effect whatsoever? That's what we mean by this first one. And then, is there a relationship between one measurement changing and the other changing? And can I make a prediction? All right, so here's the situation. The students in Mr. Carl's science class have been experimenting with different factors that they think may affect how tall a plant will grow. Each team planted seeds in several pots using different experimental conditions. With your team, read the questions that the students investigated. You're going to write a team prediction or hypothesis for the results of each experiment. Assume that all the variables are controlled, meaning that they will not be affected by, meaning that they will not affect the experimental outcome. Write your hypothesis so that it indicates a directional relationship between the independent and dependent variables. Right? What on earth does any of that mean? Okay, so let me paraphrase and summarize for you. First of all, you're not in your teams right now, so you're just going to be thinking about this on your own. A hypothesis is a scientific term for making a prediction. What do you think is going to happen as a result of what we say here? Okay. Assume that other variables are controlled. Okay, so what this means is this. In fact, I'm just going to lay out what is happening in this. We are going to be thinking about a simulation where a seed was planted, and after 3 weeks that seed will grow, and we will measure how much that seed grew over that 3-week period. Now there are certain conditions that are always going to be the same, and there's going to be one condition that changes. Those conditions are that it'll be planted in soil, in a pot, there will be fertilizer, there will be sunlight, there will be water, and there will be some things that will change. Okay, the changes can only happen once at a time. You do not want to change the sunlight and the amount of fertilizer and the amount of water for one particular example, because how do you know which one of those three is really causing it to grow? So you only want to have one variable that changes and everything else stays the same. So for every single one of these, we want to have the same size pot. We want to have the same amount of water, the same amount of sunlight, same amount of fertilizer, but we're going to change one of those items, like how many seeds we plant in the pot, keeping everything else the same. And then for another experiment, we'll change the amount of fertilizer, but keep everything else the same. And then for another experiment, we'll change the amount of sunlight and keep everything else the same. Okay, so that's what we mean by having all the other variables controlled. We're only going to change one variable and everything else stays the same. Okay, so, and then this part that says write your hypothesis so that it indicates a directional relationship. I'll give you an example with the first one. The first question is, does the amount of fertilizer affect the plant height? Now, for me, I'm thinking fertilizer is like plant food. And so the more food it gets, the more it should grow, right? So that would be kind of the idea. The more fertilizer that is used, the taller the plant will, the taller the plant height. Okay, so this is showing direction, right? The direction in that the amount of fertilizer is increasing and the height is increasing as well. So this would be like, well, I guess we'll get to the talk about the positive slopes and positive associations a little bit later, okay? But that is definitely an example of a positive association. The more fertilizer you use, the taller you expect the plant to go. All right, so look through B, C, D, and E, okay? Jot down these sentences and then write out a statement similar to the one that I wrote here for part A about the effect. What do you think will happen in this situation? Does how deep the seed is planted in each pot affect the plant's height? Now remember, we're talking after a 3-week period, not just in general, okay? So we are going to plant it, then monitor it over 3 weeks, and at the end of the 3-week period, we would measure it. So do you think the depth of the seed will affect the plant's height? Do you think that the number of seeds in the pot will affect the plant's height? Do you think the size of the pot will affect the plant height? And do you think that the number of hours that this is sitting in sunlight will affect the plant's height? Go ahead and jot down what you think would be your hypothesis or your prediction, and I will show you what my predictions were after I unpause. Okay, hopefully you've spent some quality time doing that. Let's see. How deep the plant or the seed is planted, does that affect the height of the plant? And I think it will. I think a 3-week period, like eventually all the plants would end up being the same height. But after 3 weeks only, it's going to take a little bit of time for the plant to reach the surface. Like something that's planted an inch below the surface will pop out pretty quickly, but something that's planted 10 inches below the surface will take a while before it makes it up there. Seems logical. Does the number of seeds in each pot affect the plant height? I'm tempted to say no, and sometimes when you put too many seeds in, the roots start to run into each other, and maybe they start choking each other. So I'm thinking that the more seeds you use, the shorter the plant would be, because it would sort of stunt the growth. Now remember, it could be absolutely wrong. I don't really care. I'm just making a hypothesis, and then I'm going to observe it. To me, that kind of makes sense. But then if you said it wouldn't have any effect, that would make sense too. D, does the size of the pot affect the plant height? I don't think that makes any difference. You can have a huge pot with one seed in there, or you could have a relatively small pot. I think in 3 weeks, it's not going to make much of a difference. I think in a year, it might make a difference, but in 3 weeks, no. And then does the number of hours of sunlight per day affect the plant height? I think that definitely is going to make the plant taller, right? The more sunlight you get, the more nutrients it gets from the sun, photosynthesis, it's going to grow a little bit more. So that's what I think is going to happen. So now what we get to do is we're not actually going to plant these seeds. What we're going to do is we're going to look at the table that was created by each one of these teams who actually conducted each one of these experiments. We've got 5 different ones, right? A through, 5 different ones that we're going to inspect. So what we need to do is have graph paper available, and we're going to create a coordinate grid. We're just going to create a scatter plot, and we don't need to have any of the negative values in there. So let's create a scatter plot and make sure that we label our X and our Y axis. The X-axis, the X-axis is your independent. In this case, we're trying to see the effect of fertilizer on the plant height. So the number of milliliters of fertilizer is going to be on the X-axis, and the height of the plant will be the y-axis. In fact, in all of these, the height will always be the y-axis. So let's go ahead and label that as y, and this is x. And then it did say to put a title on your graph, but I didn't. This would be the title right there that we could put right there. All right, so this is what we're going to do. We're going to take this table of values, and we're going to plot these points. So 5, for a plant that received 5 milliliters of fertilizer after 3 weeks, it grew to be 14 centimeters tall. 10 milliliters grew to be 17. Because that 17 is probably right around there. It doesn't have to be perfect. I think I am a perfectionist though, so I'm going to put that right around there. Okay. And 15 is 21. And 20 is 31. And 25 is 33. And 30 is 40. All right. Now, here's the key. If it forms a pretty straight line, that's an indication that there's absolutely a connection or a correlation between the amount of fertilizer used and the height of the plant. And this does really come close to a straight line, right? If we were to create a line of best fit, it would go something like that. And that's a very strong correlation. So we can say absolutely the amount of fertilizer that is used absolutely affected the plant height, right? The plants that used more fertilizer were much taller than the plants that used just a little bit of fertilizer. Okay, so our hypothesis for the first situation A was correct. The more fertilizer used, the taller the plant. Okay, so I just showed you how to do this one. What we're going to do is the next 4, and I will pause the video. I will show you all the data. You pause the video and you create the coordinate grid and then plot the points, and then you make up your mind yourself. Does there appear to be a connection between the amount of one thing affecting the height of the plant? Okay, so here are the different tables, but I've gone ahead and done it like this. So situation number 2 is asking, does the depth of the seed in the plant affect the plant height? So please pause the video, and you can just go ahead and copy down what I've got right here. This is your y-axis, this is your x-axis. This is the depth of the seed in centimeters. This is the height of the plant in centimeters. Put parentheses around that if you want to. And then go ahead and plot these, make a scatter plot, and see if there appears to be an association or a correlation between the data. I'm going to do the exact same thing. So when I unpause, you should be done. So make sure you pause this so that you don't accidentally see the graph before you're ready, okay? When I unpause, I'm going to have the graph there. All right. That's a strong correlation too. It's going in the opposite direction though, right? It is going kind of in a straight line. Looks like the line of best fit would pass somewhere around here. And it absolutely looks like the deeper the seed is planted, the shorter the plant is after 3 weeks. In fact, the one seed that was planted 18 centimeters below the surface never ever made it out of the dirt. It never grew, so it stayed at 0. So yeah, definitely the deeper the seed is planted, the shorter the height of the plant. All right, how about 3? Does the number of seeds in each pot affect the plant? Go ahead and pause. Remember, this is your y-axis, this is your x-axis. Go ahead and scale it however you want, but you can copy my scaling. We're going to put the independent variable, the number of seeds in the pot, is going to be on the x-axis, okay? Go ahead and pause and then plot those points. All right, what do you notice about this? I thought that the more seeds that were planted in the pot would cause the height to be lower, but I was thinking that it would be like dozens of seeds, not between 1 and 6. So I think you could pretty much say that it really doesn't have much of an effect on the height of the plants. I mean, here you've got this situation where you've got none of them get more than 27 and none of them get lower than 20. So regardless of the number of of seeds in there, they all fall within that range. So the number of seeds really didn't have much of an effect at all on the height. And maybe that's what you predicted, and that's probably was the more logical prediction, but I decided to take a chance with my hypothesis. All right, let's move on to the next one. The next one says, does the size of the pot have any effect on the plant height? This is one where I thought it wouldn't make any difference at all. So let's see what happens. Go ahead and pause and plot your points and unpause when you're ready. All right, that's what I expected on this one. So this one and the previous one were similar, where you had your, you had your upper range, upper limit, and your lower limit, but they all fell somewhere within there. So, it's having a bigger pot really didn't make much of a difference. Here you had a 15-centimeter diameter compared to a 3-centimeter diameter, and this is only 1 centimeter taller than that one, and this one was even shorter than those. So, yeah, no real correlation there between the size of the pot and the height of the plant. And then the last one, does the number of hours of sunlight per day affect the plant height? I thought, yes, it actually would, that the more sunlight it gets, the higher the plant would grow. Let's take a look at the data, put in the scatter plot, and see if we see a correlation. Alrighty, there we are. Definitely a strong correlation there. Let me go ahead and put in this. Line of best fit, going through all that data, the points never stray too far away from your line of best fit. That indicates a strong positive correlation between the data, meaning that the amount of sunlight absolutely affects the height of your plant. The more sunlight you get, the taller the plant grows. All right, so let's take a look at a few different ways that we can describe association. When we're looking at a scatter plot, if you tend to have the data going in this direction, as x increases, y also increases, that results in what we call a positive association. Now, let me tie this into something that you've already learned. You recall when we learned about the slope ratio, when we were talking about y equals mx plus b. The slope ratio is the ratio of the rise over the run, or the change in y over the change in x. When both of those are equal to positive numbers, say x or y goes up 3 when x goes up 2, that would be considered a positive slope, right, or a positive growth rate. So this direction on the line indicates x increasing, going in the positive direction, and y going in the positive direction. So that would be a positive association. Okay. Now, when we're going in this direction, x is increasing, so that would be like x is increasing by 2, but y goes down by 1. So that would be not a positive number, but a negative number, right? A negative slope to the line. So when x increases, y goes down. That's considered a negative association. Okay. And then you look at this, and it's like impossible to determine which direction the line would go. Is it supposed to be here? Is it supposed to be there? Is it supposed to be there? It's impossible to tell because the scatter plot literally has points scattered all over the place. So there's no way of drawing any conclusions about this data. So there would be no association for that data. Then we talk about the form of the association. Generally, you've got 3 forms. You've got linear, nonlinear, and then this one, which is called clusters. I don't really see that too often. But the linear form is like this. When you look at it, it looks like it would form a straight line, just like this one did and this one did, and many of our examples in today's lesson. The nonlinear would be something that would be shaped in a curve in some sort of a way. Yeah, sometimes you have your scatter plot. When you look at the direction and the form, you kind of get an idea of what type of rule might work for that situation, whereas this one might fall into the y equals k over x kind of an approach for a rule. And you may not have recognized that this would be the shape of a curve, but you'll get to that as we move on. And then the clusters, it does form kind of a straight line, but you got a majority here and a majority there with a few in the middle. So it's kind of like bimodal data, that sort of a thing. And then the last big idea here is the idea of whether or not there's an outlier in the data. Okay, so you see this point right there? That's an outlier. Okay, most of the data is clinging to your line of best fit, clinging to the line of best fit somewhere in these clusters. When you get one piece of data that does not fit with the rest of them, that's the definition of an outlier. And so a lot of times with the outliers, we'll just kind of ignore the outlier and just focus on the majority of the points that stick to the trend, okay? So that concludes our lesson, and I would like to say that it was only a 20 to 21 minute lesson, but I know that it takes a lot of time to set up each one of those graphs, so I'm sure it took you a little bit longer. So thank you for sticking with it and completing all of the elements of this particular lesson. Let's move on to our next activity. Take care.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,